Hello, I'm Robert Taylor, Senior Site Reliability Engineer at Adobe, here to talk about Azure Cache for Redis Enterprise Tier with the Redis Bloom module and our use of it on my team at Adobe. The subtitle of this talk is Managed Highly Available Bloom Filter for Reliable High Throughput Deduplication, also known as Don't Spam My Phone. That's what we're going to talk about. In this talk, I'm going to present who I am and a little bit about my team. Also, the challenge that we faced in developing a second-generation push messaging service. Our use of probabilistic data structures for deduplication. The solution and why we chose it. How we implemented it and results. Some resource links and some takeaways. So this is me, Robert Robot Taylor, Senior Site Reliability Engineer at Adobe. And I've been with Adobe since 2014, about the time this picture was taken. And this is how it's going. Anyway, I've been a Senior Site Reliability Engineer with mobile services for about 7 years. And what I'm going to talk about today is specifically relating to our high throughput push messaging service. About Adobe. Adobe is big and has a lot of products and services. My team specifically is the Adobe Experience Platform Mobile Services Engineering team. The overall team is responsible for SDKs and API services provided to mobile developers, and these APIs and SDKs integrate with the larger digital experience portfolio at Adobe. The team that I'm assigned to currently is 7 members, 6 of which are here. I took a photo from our stand-up. And we're responsible currently for 4 services that are in production, 1 that's in development, and 1 that's awaiting development in the wings. The point here being that we are a product engineering team, not a platform engineering team, and that factors highly into this talk. The challenge we faced was taking an existing push message service that we currently operate and manage and improving it, specifically improving throughput 1,500%, reliably preventing duplicate push messages, making sure that deduplication is not a bottleneck, reducing our operational overhead, and keeping costs low. So with these requirements, we began our second generation of our push messaging service. The workflow of our push messaging service begins outside of push messaging with our message authoring system. And this is upstream from us, managed by another team at Adobe. A message is content that is meant to be sent to subscribers of that message. There may be millions of subscribers to an individual message. A message may be something like a sports score update. So a Adobe customer provides sports score updates to its subscribers. This becomes a message when combined with the recipients is bundled together into a batch. This batch is a job and it's sent over to a message broker. In our case, this is Apache Kafka. Our service begins here, consuming from Apache Kafka. The push messaging service consumes, it combines the message batch with the proper credentials to be sent through eventually to the appropriate push provider, either Apple or Google. And in the middle, we have to take responsibility for deduplication. There's many reasons for duplicate messages occurring, one of which is that the way we're using Apache Kafka is, for example, if there's a rebalancing of partitions, we bear the responsibility for making sure that we don't have duplicates. So we have to have deduplication on our side. So deduplication becomes important. Now, why? Well, very simply, you may have a mobile phone and you may subscribe to receive push notifications for messages, say the sports score update example. When that event occurs, you get the notification that the sporting event had an update in the scoring, and you're happy, or maybe you're sad, but anyway, you're glad to receive the message. It was important to you. If a few minutes later, or even a few seconds later, you receive a duplicate message of the same event, you are no longer happy. You probably will go to Twitter and tweet fire, and you may complain to our customer, why did they send you this message twice? The customer will then contact Adobe, who will contact me in the middle of the night and ask me why we sent a duplicate message. None of us need that in our life. So deduplication is a requirement in push messaging. It's so disruptive, right? Years ago, we decided in our initial push messaging service to utilize a probabilistic data structure, Bloom filter. Now, probabilistic means it's not a guaranteed 100% yes, no on whether something is a duplicate or not. In fact, it's a guaranteed no in the sense that we know if the Bloom filter indicates that a message ID is not a duplicate, it's 100% guaranteed that it is not a duplicate. This is a unique push ID, and we can send to that recipient. However, because of the probabilistic nature, there's a small chance that we can get a false positive, meaning that we err on the side of not sending a message if we suspect it could be a duplicate. Now, why would we do this? Because we do have a tolerance for some errors on the side of a false positive. And this allows us to have a very efficient memory footprint in the deduplication service, and it's extremely fast. Less resources, lower memory, lower cost, very fast, good. So we use Bloom filter. One of the things that, because of the integral nature of the deduplication service, if there is any reliability concern at all, if we can't reach the service, we have to stop processing. Well, yes, this does stop the sending of duplicates, but it also stops the sending of messages at all. And that violates other agreements that we have with our customers that when they want to send a message, we will. So we need to make sure that our deduplication service is reliable. And one of the problems that we faced with our initial service is that we had a single point of failure. Because it is such a small memory footprint, our deduplication service initially was able to be run in a container, self-contained, using active memory only. And as you may be aware, using a container orchestration system, if the orchestrator thinks that the container is unhealthy, it will restart that, replacing it and giving you fresh new memory to use. Well, if you're in the middle of a batch job, this could be very bad because you lose your context of where you are in processing of push IDs to see if they're duplicates or not. In this case, if this did occur, and it did occur to us once, we need to stop processing or we're going to send duplicates. And it's a very bad situation. We had to solve it by adding some resiliency. The other challenge was who manages the platform. Now, with our initial push messaging system, we not only ran the service, we managed the platform. It was on a platform that we managed ourselves. And for our next generation push messaging, we wanted to use managed platforms as much as possible to leverage the expertise of dedicated platform engineering teams, either within Adobe or at one of our cloud providers like Azure. So if we're going to add resilience to our service, we had some choices to make. So in evaluating the choices, we had some criteria. First of all, we knew the service had to be fast. It had to be reliable, right? And then it needed to be secure. That goes without saying. Then it has to be cost effective. We have to be able to afford this. And costs can be either direct infrastructure cost or they could be the overhead of managing a platform. And it should be a managed service, if at all possible. So as we began to filter through our choices, adding resilience ourselves, using some product off the shelf that we stood up and maintained, or a direct managed service, we came across last year a new option. And that was at RedisConf 2020. We heard about Redis Bloom Enterprise, the module with the enterprise version being offered through Azure through a product that we could use as a service managed for us. And This became very interesting. So we had to investigate. We applied to the private beta and we got in. And what we were looking to do is to see if we could use the Azure Cache with Redis Enterprise tier with the Redis Bloom module as a drop-in replacement for the code that we have written that would offer resiliency that we didn't already have, and we can consume as a service. That began our investigation. So let's talk about how we implement the Azure Cache for Redis Enterprise tier with Redis Bloom. Besides using the Azure portal, which is what we initially started with the private beta, in March of 2021, the Azure RM provider, available at the Terraform registry, added support for the Redis Enterprise cluster and database. And this is kind of what it looks like. So in a sample TF file that you might have, bypassing the creating of a resource group and other things that you might need in your environment, the keys here for the Redis Enterprise are simply two different sections. The first section is for the enterprise cluster, where you give it a name that you've created. You assign it to a resource group for good grouping. You set a location, which you could use, say, the one everyone uses, East US, and you provide a SKU name. And in our case, we use Enterprise E10, which is the smallest full memory DRAM-based instance. And then you set in your zones and assign your tags. Then you create your database itself. You set a name, which it's limited right now to default, which is fine for us because we are a single use only. We're not using any other, we have no other key type. It's just the Redis Bloom. So the name doesn't matter to us. You assign it to the cluster that you just created. You assign a client protocol, which could be TLS or plain text if you're adventurous. And then you set an eviction policy. In our case, we use volatile TTL to kick out the oldest keys if kicking out keys is essential. And then you refer to your module, in our case, Redis Bloom. And that's it. Pretty simple. Next, we need to have client-side support. So we're using a Java application in this case, and there's a lot of different client libraries to choose from. But because we don't need clustering due to the small memory needs for the Redis Bloom itself, and the ability to add pass-through native commands to the Bloom filter itself, we chose Redis. It's small and fast for this purpose. We just need to configure the pool, set the initial capacity of the Redis Bloom, set the acceptable error rate. Remember, we're erring on the side of false positives. And then we actually issue the command itself to add to the Bloom filter and get the results. And this is what it looks like. So in this class, we're using Redis, establishing a pool, and then building the pass-through command. So the pass-through command will be a unique key that then has a capacity set, initial capacity. It can grow if necessary. The acceptable error rate, which is predetermined in our case. And then we add the items themselves, which would be the recipients. We set a pipeline because we're actually going to issue two commands. First, we have a single command to the Bloom filter, which is an insert, which does a reserve and an add in one step. So fewer steps, better for us. And then we set the TTL as we add to the keys so that our key is always fresh until it's no longer in use, and then eventually it expires, clearing memory automatically. We get the results back, and of course, if we suspect it's a duplicate, we just remove it. It's not worth investigating any further. We just take it out. When we're done, we have a list of clean IDs, and we can push this to the push providers with assurance that we will not get a duplicate or a call in the middle of the night because of one. So, results. Well, we see operationally I can stand it up, and functionally it should work. But the real question is on throughput. Is this going to be a bottleneck or not? So this is the next thing we had to test. And in testing whether a component to a workflow is a bottleneck, what I like to do is run the workflow with that component in question removed. So you bypass that component. In this case, we would bypass deduplication. So we set up a test. So we had 60 million messages pushed through to a test environment, standalone Kafka, standalone container cluster, and we see how fast we can consume and push. And in this case, we were able to push up to 150,000 requests per second. All right? This became our baseline with this configuration. Then we ran the test again, unfortunately with a little bit different data set, only about 50 million messages this time, but close enough. Ran the test again, and sure enough, with duplication enabled, that means using the Azure Cache for Redis Enterprise tier, we hit the 150,000 requests per second again. So on a rough basis, we could see that we did not have a bottleneck with the Redis cache. And this was great. Now we can dig in deeper and see if there were some latency issues or if there were other places that we could improve client access code or things around accessing the module. But that's for perfecting. This was a test just to see, are we going down the right track? And the answer was, yeah, we're fine. Okay, what could be better? First of all, there are metrics in Azure available for the cluster. However, I'm not able to set alerts in the Azure portal. I would like to be able to set alerts in the Azure portal, and the reason being that even though I'm able to export the metrics with the Grafana data source for the Azure monitor, so I'm able to receive the metrics in Grafana and set alerts there. It's not optimal to set alerts in Grafana. I'd rather have alerts in Grafana, but also have alerts over in Azure for some reliability in the metrics. Also, I'm able, with other monitoring through our application, to detect certain error conditions that may be present. But I want to have alerts on all sides of the equation, and that would be over at Azure. So metrics with alert support would be great. Second, a native Redis command to set and expire TTL. This was mentioned by one of my other engineers. I'm just throwing it out there. And the third, I mentioned that we're using the smallest instance tier right now, the E10. And actually, for a lot of our use cases, especially outside of production, it's too much capacity. We can't use it all. And some other teams at Adobe had asked us about using the Azure Cache for Redis Enterprise tier for their own deduplication needs, but their data footprint is even smaller than ours. And it's hard for them to justify the infrastructure costs, even standing up for a temporary basis, when they don't come close to using the 12 gigabytes available. So that would be nice to have. And then the last thing that I think could be better is a serverless option, but I always think that. I'm one of those people that loves serverless options. Here's some resource links. Really simple. So the Azure Redis Enterprise documentation over at Azure, the Terraform Azure RM provider documentation. There's really just two sections, cluster and database. And then, because I mentioned Redis, a link to the Redis repo over at GitHub. Okay, time for takeaways. The first one is, as a product engineering team, we like to focus on managed services that are provided by platform engineering teams. Let each team focus on its specialty. I think it works best that way, but that's my opinion. Secondly, managed Redis Enterprise with module support really stands out to me. For years, we've been using managed Redis in general at various providers, but the addition of module support with the other capabilities for high availability and some of the advanced clustering options are attractive, but the module support really stands out. This is the first time I've seen that offered, and it's great. And then lastly, it's managed by Azure. And if you're also a development engineer on at the enterprise, you may appreciate this. A new product from a new vendor oftentimes has to go through a lengthy procurement phase with vendor vetting and paperwork and delays. But if you already have a relationship, as we did with Azure, since this product is made available directly from Azure, we were able to bypass that delay time. And so while we're rapidly innovating in this product development, we weren't slowed down through the procurement phase because it was offered through Azure. And that's it. Thank you for attending and listening my talk. And if you have any questions or follow up, please email me, robot_Taylor@adobe.com.